This is Bernoulli's equation. Now, in a Bernoulli's equation, the format or the standard format that we're supposed to follow in a Bernoulli's equation is dy over dx plus p of xy, which is equivalent to q of x y raised to n. If you have noticed in our discussion about linear differential equation, we have this formula dy over dx plus p of x raised to y is equivalent to q of x times y raised to n. I mean, q of x, we do not have y to n. This is our formula or standard format in a linear differential equation. So we have here the difference in a Bernoulli's equation. We have y raised to n. So you have another term after q of x. In LDE, you have here q of x. Okay. So these are the difference between the Bernoulli's equation and linear differential equation. Now, if we have dy over dx plus p of xy equals q of xy to the n, this is linear in y, then if the equation is linear in x, then we will be using this dx over dy plus p of y x, which is equivalent to q of y x raised to n instead of y to the n, you have here x to the n. So when we solve Bernoulli's equation, we have y raised to negative n dy over dx. In other words, whatever is your value here, y raised to n, you will multiply its reciprocal. Take note also that your n here, or the exponent, if the exponent is y, let's say your n is equivalent to 1, we can make use of uh, separation of variables if n is equal to 1. Thus, in a Bernoulli's equation, we are supposed to have our n not equal to 1. So let's say n is equal to 2, n equals 3, n is equal to 4, and so on. So if that is the case, then we can make use of this Bernoulli's equation. So going back to this format of Bernoulli's equation, our way of solving this one is to, after we follow this format, we will multiply this y raised to n to all the equation. And then after that, we will apply substitution, wherein let v equals y raised to 1 minus n, this one. Whatever be the value of your y here, y raised to 1 minus n, then let v equals y raised to 1 minus n. So these are the process of solving Bernoulli's equation. Now, before we have our example, don't forget to subscribe my YouTube channel, Tom TV, so that you will be notified whenever I upload some of the videos related to mathematics equation. Okay, we have our example number 1, y times 6y squared minus x minus 1 dx plus 2x dy is equal to 0. Now, if you have noticed for this equation, we cannot solve this one using separation of variables because we have here a combination of 6y squared minus x minus 1. Also, we cannot solve using homogeneous equation because the degrees are not equal. And then exact, if you want to check the exactness of this equation, well, you have to check. So most probably, and then also we have this linear differential equation. Of course, this is not linear differential equation. So instead, and also, we also have this substitution suggested by the equation. But then there is no like terms for your mdx plus ndy. Thus, this equation can be solved using Bernoulli's equation. So to solve this one using Bernoulli's equation, take note for your mdx and your ndy, ndy is much simpler compared to mdx. Thus, we will make use of dy over dx plus p of x y is equivalent to q of x y raised to n. So we will be using this one, q of x raised to y. I will write this one, q of, okay, q of x y raised to n. Okay, so that's it. Q of x y raised to n. Now, we will format this one based to the Bernoulli's equation general form. So, we will distribute this y times 6y squared. So, that is equivalent to 6y. I will write this one here, and then I will erase this one later on after I will transfer. So 6y cube minus 6y times negative x, that is negative xy minus y, and then multiplied by dx plus 2x dy is equivalent to 0. Now, since this is simpler, I will make use of dy over dx. Thus, I will transfer dx as your denominator to dy. Okay, so we have here 6y cubed minus xy minus y, and then plus 2x dy over dx. And also 2x, I will transfer 2x to this group, so that you will have 6y cubed minus xy minus y all over 2x. That is equivalent, plus dy over dx is equivalent to 0. We have here equivalent to 0. And so, if we combine this one, 6 divided by 2x, that is 3y cubed. 3y cubed, we have here 3y cubed over x. I will write here 3y cubed over x minus y over 2 minus y over 2x plus dy over dx. That is equivalent to 0. Okay, so by rearranging this one, following this format, okay, by following this format, I will write dy over dx first. Okay, so I will write here dy over dx. Okay, and then if you have noticed, y raised to 3 or y has an exponent of raised to 3. So most probably this one will be our q of x y to the n, because this has no exponent. So this will be our p of x y, this part. So in other words, this one will be transferred to the other side. That will be our q of x y to the n. So I will write first these two terms. We have minus y over 2 minus y over 2x for this part. Okay, And then this one will be transferred to the other side. So that is equivalent to negative 3y cubed. Or I will write here negative 3x 3 over x y cubed. Okay, so we have this one dy over dx minus y over 2 minus y over 2x plus, I mean, this one we already write dy over dx, and then equals to, we transpose this one to the other side, that becomes negative 3 y cubed over x. Okay, so we have already this one. This time I will erase this one, okay, because I'm doing this one because my space is limited, so I will erase now this one. At least I already explained how we arrive to this equation, which is coming from this one. So I will erase this part. This time we have y raised to 3 as our y to the n. So the next step is to multiply both sides of the equation by the reciprocal of y to the n. So y that is y raised to negative n. So for this case, we will multiply it by y raised to negative 3. So that the result here is y negative 3 dy over dx minus, okay, minus y. So, okay, y minus y raised to negative 2. Negative 2. By the way, in this part, I will write here negative y over 2 minus y over 2x. If we multiplied by y negative 3 for this part, you have here negative. By the way, I want to factor this one first. So we have here negative y times 1 over 2 plus 1 over 2x y raised to negative 3. So that I can only multiply y negative 3 to y. That is equivalent to negative y raised to negative 2. And then you have here 1 half plus 1 over 2x. Okay, so this is how we distribute y negative 3 to these two equations. So I will write here y negative 2 times 1 half plus 1 over 2x. Okay, so what remains on this part is this one, that is negative 3, and then, okay, negative 3 over x. Okay, so we have the value of this part. Now, after we multiply this one, of course, we will now make some substitution. Okay, so again, I will erase this part. I will erase this part so that I have an empty space when we solve this equation. Okay, after I erase, this time, take note, we already have this one. Now the next step is to make a substitution y equals negative 2. So we have let's say v, that is equivalent to y negative 2. Whatever be the value here from our p of xy, whatever is your y, you have to apply let v equals the value here for your y. So that the derivative of y, I mean v, is equivalent to negative 2y negative 3 dv. Okay? Now, if you have noticed on this part, you have here y negative 3 dy. Okay, sorry, this is dy. Now, negative y negative 3 dy. So we need to have this one so that we can substitute the value. So we have here y negative 3 dy. So we have dv over negative 2 is equivalent to y negative 3 dy. So we will substitute this one to our y negative 3 dy so that we have dv over negative 2 instead of y negative 3 dy. So we will write dv over negative 2 and then dx. Okay, we substitute y negative 3 dy as dv over 2, negative 2. And then for this case, okay, so we have substituted already. Okay, so for this case, we will just copy this part, minus y negative 2 1/2 plus 1 over 2x equals negative 3 over x. Now, after we have this one, of course, we need to uh, remove negative 2. Therefore, we have to multiply it by negative 2 to both sides. So that is negative 2. So that what remains here is dv over dx. Negative 2 times negative, that becomes positive, plus 2, 2y negative 2, and then 1/2 plus, okay, so I will just multiply the negative sign, and then this 2 will be multiplied to this number so that we can have a, so we have here plus, okay, sorry, I will rewrite it again, plus y negative 2. Instead of multiplying negative 2 to y negative 2, I will just multiply negative 2 to this part. So that the result is negative 2 times 1/2. Negative 2 times negative, that becomes positive. So we only multiply 2 to this one. So 2 times 1/2, that is 1, plus 1 over x, which is equivalent to 6 over x. Okay. Now, if you have noticed, this is linear differential equation. For this case, this is linear differential equation. Okay. Now, by the way, we have here our y raised to negative 2. We substitute the value of dv over negative 2. So this y raised to negative 2, we will substitute also by v, because we already have there's no y dy here. So we will substitute y negative 2 as v. So I will erase this one and substitute it as v. Okay, so v, and then we have here v. So that our variable now is v and x. So this is again linear differential equation wherein this is linear in v. Linear in v. Therefore, if that's linear in v, then we will make use of our integrating factor, which is e raised to the integral of p of x dx. Okay, so we have here e raised to the integral of our p of x equals, okay, we'll write here in e raised to the integral of 1 plus 1 over x dx. Okay, so that the result here for the integral of 1 dx, that is x, and the integral of 1 over x dx, that is ln x plus ln x, so that this is equivalent to e to the x, e to the ln of x, and then this e to the ln of x, we have here e to the x, this is equivalent to x. Okay, So we have here our integration factor. Now, our integration factor will be multiplied to this group so that the result is we go directly by multiplying e to the x by v. So that is the result, which is equivalent to vx e to the x. We just multiply this one directly. Okay, v times x times e to the x, which is equivalent to the integral of 6 over x times x e to the x dx, wherein you can cancel x. So the result here is 6e to the x dx, so that we have here our vx e to the x, and then the integral of 6 over, you can cancel x, that is 6e to the x, that is 6e to the x plus c. Okay, thus we have here supposed to be our general solution, but we have v in terms of v. So we go back to substitution by substituting the value of v as y negative 2. So that we have here y negative 2. So I will erase this one now. I will erase this one, or I will have to move this one. Okay, so that I have an extra space. So we have y negative 2. This is y negative 2. And then we have here x equals 6 x plus c. Since we have here y negative 2, we will make it as positive. So we will have a multiplier, which is y raised to 2. It's reciprocal. So that our final answer will be, okay, I will erase this one. Our final answer now is, when we multiply this one to this part, we have x e to the x. And then to this part, we have, okay, we have equals 6y squared e to the x plus c y squared. Okay, so this will be our final answer for this example. This time we will have another example. We have 6y squared dx minus x times 2x cubed plus y dy. That is equivalent to 0. Now this time, if you have noticed, 6y squared dx is simpler compared to dy. Therefore, we need to have our Bernoulli's equation, which is dx over dy. Okay, because this is dx, and then this is simpler compared to dy. So that dx over dy plus this time, this is p of y, x, which is equivalent to q of y, and then x to the n power. So we will be using this Bernoulli's equation. So we will arrange this one in terms of this equation. Okay, so again, I will write here my equation, so that we have here 6y squared dx. Okay, I will distribute this one first. Okay, I will transfer, okay, sorry, dx, and then minus 2x to the fourth. Okay, 2x to the fourth, 2x to the fourth, minus xy. Okay. And then we have minus xy dy, which is equivalent to, so I will have here plus, equivalent to 0. And then by transferring dy to the other side, that becomes 6y squared dx over dy, which is equivalent to, minus 2x to the fourth minus xy, which is equivalent to 0. And then I will transfer the 6y squared to this part. So I will divide, or I will multiply the reciprocal of 6y squared to both sides. You have here 1 over 6y squared. So the result now is dx over dy 1 over 6y squared times this one, that is minus 2 over 6, that is 1/3. So x to the fourth over 3y squared. And then this one multiplied, so we have here minus x over 6y, which is equivalent to 0. Now, after we have this one, of course, we have now followed this equation. And if you have noticed, this is dx over dy, this is dx over dy, and this is x to the n. So we have choose this one as our qy x to the n, because x has an exponent raised to 4. So that will be our n, x raised to 4. Okay, so I will rewrite this one into this equation. So I will copy dx over dy, and then we have this part will be transferred to the other side. So we have 1, okay, so minus 1 over 6y, because this is p of y, x, so I will separate x, okay, and then that is equivalent to, this one will be transferred to the other side, that becomes positive 1 over 3y squared, and then this is x raised to 4. Okay, so we have already this one following this format. Okay, now after we follow this format, of course we have here x to the fourth, we must multiply its reciprocal. So we will write here the reciprocal of x to the fourth, which is x raised to negative 4. So when we multiply this one, so this will become x negative 4, and then dx over dy, and then minus 1 over 6y, 1 over 6y, x negative 3. And then this one, of course, 1 over 3y squared. Okay, so I will erase this part. Okay, so this time we will proceed to substitution. Okay, so let v, substitution, let v equals, so whatever be the value here, that is x negative 3, we will make use of let b equals this one, x negative 3. And then we take the derivative of v, which is equivalent to negative 3 x negative 4 dx. So if you have noticed x negative 4 dx, we need this one to substitute to this part, so that dv over negative 3 equals x negative 4 dx. Okay, so this time we will substitute x to the fourth dx as dv over negative 3. So we have dv over negative 3 dy minus 1 over 6y. Then this time we will substitute x negative 3 as v. So we have here v equals 1 over 3 y squared. So we did the substitution method, and then when we have here negative 3, then we will multiply both sides by negative 3 so that we can delete this one. So negative 3 times this part, you have here dv over dy, which is minus negative times positive. So we will make this one as positive plus 3 over 6. That is 1/2 over 1 over 2y. 1 over 2y. This is negative, negative, that becomes positive, and then we have here v, which is equivalent to negative 3, and then times 1/3, that becomes negative 1 over y squared. Okay? Now, after this one, y squared, we have already dv over dy plus 1 over 2y v equals negative 1 over y squared. So for this part, this is again linear differential equation, which is linear in V. So if this is linear in V, then we will make use of our integrating factor, which is, okay, I will write our integrating factor, integral of, we have this one, 1 over 2y dy, which is equivalent to e raised to 1/2 ln y, or that is equivalent to, okay, raised to 1/2 e ln y raised to 1/2, or square root. So we have here e ln square root of y, or that is equivalent to square root of y. Okay, so we have here our integrating factor. Once we have our integrating factor, we will multiply this integrating factor to the whole equation. Okay, or we go directly by multiplying this integrating factor by your v. Okay, that is the shortcut for LDE, linear differential equation. Whatever is your e, we will multiply this one to your v, this part, your supposed to be your x. Okay, so we will multiply v square root of y directly, and then take this one as your integral of course you have to multiply this one by your integral. Okay, I will write here, okay, I will write here the negative sign, and then y raised to, okay, this is y raised to negative 2, this one, and then this is your, if we multiply this one, you have, okay, I will write here y negative 2 times your integrating factor y raised to 1/2 dy. Okay, now if we multiply y negative 2 to y raised to 1/2, you have to subtract the exponent, negative 2, add the exponent, so negative 2 plus 1/2, that is negative 3/2. Using your calculator, it will result to negative 3/2 y raised to negative 3/2 dy. So the integral of negative 3/2 dy is equivalent to, okay, I will write here b square root of y, which is equivalent to negative integral of y negative 3/2 dy. Okay, now I will delete this part. Okay, I will delete this part. Okay, so that I have an extra space. Now, v square root of y equals this one, integral, that is plus 1 plus 1, that is 1/2. So negative y raised to negative 1/2 over negative 1/2. Okay, negative 1/2 plus negative 1/2. plus c. Okay. Now, this time, of course, this is negative 1/2. This is negative times negative, positive, and then this negative 1/2 will becomes positive 2. Okay. I will have here positive 2. That is negative 1 over 2. Let's say y negative 2. So that this is equivalent to negative, negative, positive. This is y negative 2 and then 2 over 1. So that's the result why we have here 2 times y negative 2. We have this one. Okay. So I will erase this one. Okay. V square root of y. Now, this is the exponent is negative. So we will multiply it by positive exponent, and then we will substitute v. Okay, later we will have this one. We will substitute, later we will substitute v. So we will compute first this y raised to negative 1/2, right? So supposed to be, we will multiply it by y, the reciprocal of this negative 1/2, so 1/2. So if we multiply all the equation, we have the result here is v y to the 1/2 times y to the 1/2, that becomes y, which is equivalent to 2 y 1/2 times y negative 1/2, that is 1. And then plus c is square root of y. So 1/2 times c square root of y. Now take note, v is equivalent to x negative 3. So we will substitute x negative 3 for this case. So that is x negative 3 y equals 2 plus c is square root of y. Since this is negative, we make it positive. So we will multiply it by x raised to 3, the reciprocal. So this will be cancelled. So the result here equals y equals 2x cubed plus c x cubed y square root of y, or y raised to 1/2. So I will write here square root of y. So this will be our final answer for example number 2.